okay? So when you're taking your midterm, you'll hand that in and you'll get everything back when we come back from spring break, okay?
Are we also get a formula sheet on the final?
Yes, but you're going to have to make choices by then. You're going to have to cut some things off for sure. But for sure, you'll have all your derivatives memorized by then. So just to look back at implicit, right? This is section 3.5, implicit differentiation, right? I want to look at my favorite problem and tell me if I did this last class. Tangent of x plus y is equal to x. Did I do that? No? Nice. So this is on every single midterm I give, but I change. What could I change? What do you see here I could change? The trig function. What else could I change? I could change the variables, right? I can do anything I want to the variables. And the key is we're going to have to take a derivative, right, of the outside and the inside. Okay, but there's another piece that's essential, and this is the main question here, is when I see a trig, what else do I see? As a mathematician, if I see a trig function, what else do I see? It's not on the page right now, but if I see a trig function, what do I know? A triangle, right triangle. So anytime I see a trig function, I'm going to think of the simplest version, tangent of theta is x. And this is going to give me a right triangle every time. Sometimes I won't need it. Sometimes I will. I'm using alpha instead of theta, okay? But I know what the definition of tangent is. It's a ratio of the opposite over the adjacent. So that must be x over 1. Because what is x over 1? X. So tangent is x over 1, right? So I can now label my two of my sides, and using the Pythagorean theorem, I can get the remaining side is the square root of 1 plus x squared. Does anyone need to see that Pythagorean theorem? I'm fine with doing it. Anytime I'm asking you this, I'm asking you because I want to make sure you can do it. Right? Sure. So I kind of will think of that other side as c, right? A, b, and c. And I need to know what 1 squared plus x squared equals c squared, right? So c squared is 1 plus x squared. So c is the square root, right? But because, 1 plus x squared, because I'm only interested in positive sides of the triangle, I'm going to just call it the square root of 1 plus x squared. So that's the Pythagorean theorem there, right? So really only two choices when I'm finding a third side of a right triangle. It's either going to be a squared plus b squared underneath the radical, or c squared minus a leg squared, right? But I'll do one like that today for sure, okay? 90% of the time, I need to use this triangle in my answer. Sometimes I don't, okay? So I want to see it on your paper regardless. I want to see it. You're going to have to draw a triangle in section 3.5, and you're going to have to draw one in 3.6, okay?
Do you think it's a good idea to draw a triangle on every trig function?
Every time you see a trig, you need a triangle. Now, when I say find me a tangent line on the cosine curve, I don't need a trig, right? So, but you should still, if you get stuck somewhere, it might be that you need a triangle, okay?
And then how did you know to only put x on the function and like y on the
Good, because x plus y is my angle,
Yeah.
right? So x plus y is my angle. So I know that angle's inside the triangle, right? I'm trying to label the sides. Nice. I want to find y prime in terms of dot, dot, dot. So you'll see, as I do this problem, you'll see that I'm going to create this in terms of cosine. I'm going to then convert it to sine. Then I'm going to convert it to x. Then I'm going to convert it to tangent. So I'm going to do 4 problems with this one problem. Your problem will say, solve for y prime in terms of x, or etc., right? So when I'm converting back to x's, I need the triangle. That's the key, okay? So find y primes in terms of, you know what's coming. You'll see it, okay? This is the first time you're seeing this problem, so but you'll see what happens. So I want to do ddx of the left side and the right side, right? Left side is what? Tan of x plus y, and right side is x. Who's got the right side for me? 1, nice. Left side, I need a chain rule, right? And it's implicit, okay? So when I take a derivative of y in any form, I better see a y prime, right? Good, what's the derivative of tangent? Nice, secant squared, keep the cat in the box, times the derivative of the inside. I like to not be in a rush here, right? I don't want to be in a rush here. I can put this placeholder in while I'm thinking, right? So I know I need the derivative of x plus y. So I know secant squared of x plus y times what? What's our derivative there? 1 plus y prime. Nice. Everybody okay with that? I'm solving for y prime. Remember, sometimes in this test, I can find y prime easily. Sometimes I can't. If I can't, I'm not going to ask you to find it. I'm going to say just find the slope, right? But if I say find the derivative, that means I want a nice version of y prime equals, right? So I'm going to divide by secant squared. And I recognize that, don't I? What 1 over secant squared is what? Cos squared, right? And so I'm solving for y prime. Don't let me go too fast. I'm going to move that 1 to the other side. And now I would call this solve for y prime in terms of what? What do you think? What's the main thing on the right-hand side? Cosine. So this is solved for y prime in terms of cosine. So meaning I would see cosines and coefficients. I don't care what the angles are, right? Cosine is always understood to have an angle, right? So this is solved in terms of cosine. What about in terms of sine? What you think? Negative sine squared. So you have this identity from your trig class. 1 minus cos squared is sine squared, right? So I can see that this is the opposite, right? So this is minus sine squared. Everybody with me there? All those trig identities, got to have them, okay? I now want to solve in terms of x. And so the key here is I'm going back to my triangle. What do I want to look for? The ratio of sine, right? So I know that y prime is going to be the opposite of the ratio of sine squared. What's the ratio of sine? X over square root of 1 plus x squared. X over square root of 1 plus x squared. Is everybody with me? Look at that triangle again, right? There's my angle. This side is x, this side is 1. The hypotenuse is square root of 1 plus x squared. So I'm grabbing the sine ratio there, right? I'm grabbing that sine ratio, opposite over hypotenuse, to sub in for sine. This is a big piece in Calc 2. When we're doing antiderivatives, we can't do some antiderivatives until we turn them into a triangle, turn them into a trig. So this one, can simplify to what? Negative x squared over 1 plus x squared, right? Everyone there agree? Morning. Homework's on the back table, everybody, and then I have, so if you came in late, I have quizzes and homework from last week, okay? How we doing here? Strange. Strange. Haven't seen anything like this before, right? So you just got to make sure we're following a process and do a bunch. I think there's one on every single chapter 3 test and one on every single midterm I've given. I am recording, by the way, for all you that came in late. I did start, no one had questions, so I just started recording right away. I can now put this in terms of tangent. Right, in terms of tangent now. What do you think? What do you know about tangent? Yes, what else? Look at my triangle. What's tangent? Yep, so what is it? X. So anytime I see an x, I can replace it with the tangent of x plus y. So I get minus tan squared of x plus y over 1 plus tan squared of x plus y. Strange, strange, strange problem. You're going to see more of it in my inverse trig functions. Okay? Getting derivatives of inverse trig functions, you're going to see more of it. Yes, so look at my triangle. What's tangent there? Good, but even smaller than that. X over 1. So even smaller than that, it's x. Every time I see an x, I see a tangent function. Right? In fact, my original problem is tangent of theta is x. Right? So anytime I see an x, I can replace that with a tangent. Very strange, I agree. There's like I said, I think the one in the book is this one, but there's one with a sine, one with a cosine, and then all of the ones on the test where I change it, right? Where I manipulate. What do you think? We okay?
What if I use the product rule?
So there is no product here. There is no product here. Right? This is tangent of the soda machine of money. Right? You're not multiplying by money to Coke, right? You're putting the money in to get the Coke. It's a machine. So this is tangent of an angle, right? Gives me a ratio. So I got to be careful about that, right? ln of x does not equal ln times x. ln is a function, right? Cos of x does not equal cos times x, right? So you're not multiplying them. It's a machine, right? And it's telling you what the input is. So there's really no other way to do this problem at this point, okay? So get used to it. See a trig, you see a triangle. In fact, we're going one step further than that now, unless you want me to do another implicit.
Could you go down for just a second?
Sure. I'm trying not to zoom because we lose some clarity. It's still pretty bad there, but. Sure, well, if I have it in terms of sine, I certainly can find it in terms of cosecant, and if I have it in terms of cosine, I can, yes. I tend to stick to sine, cosine, and tangent. So when we do inverse trigs, I don't ever do an inverse secant or an inverse cosecant or inverse cotangent. I stick to only those. I have to simplify some things. It's just too much. It's already difficult even if I simplify. Yvonne.
So can you explain the thought process of
Yeah. I mean, I could do another one. Yeah, do another one. And then I'll try and explain more as I do it, okay? Where am I? Oh, how did I do that? That's okay. So I want to do another implicit like that. I'll say that sine of x plus y is 1 over x, okay? So you see I changed something already. I changed the trig function and I changed what it equals to, right? And of course, I want to find y prime in terms of x, right? So the question is find y prime in terms of x. This one is not so easy to get it in terms of cosine or tangent, but it is easy to get it in terms of sine. Well, no, cosine is easy because I'm going to get a derivative of cosine, right? Right? I'm getting a derivative of the sine that gives me a cosine function. So, but it's easiest to always turn these into x and then I always need the triangle. So what's our triangle here? So our first step is to figure out what triangle I need, right? So it's always going to be a right triangle, right? With an angle of alpha, whatever it is, who cares? But I need the ratio of sine, and that's opposite over hypotenuse. So there's my so far my two sides, right? You agree? Sine is opposite over hypotenuse, right? SOHCAHTOA thing, yes. And now my remaining side has to be c squared minus b squared, so square root of x squared minus 1. Does anybody want to see that with the Pythagorean theorem? I'm fine with showing that and with using the Pythagorean theorem. So this is my reference triangle. Everyone's okay? Good. I want to find my derivative of both sides. So d dx of sine of x plus y should equal d dx of 1 over x. Both sides are easy, right? Because we did the tangent a minute ago. So derivative of sine is cosine of x plus y times 1 plus y prime. Who can tell me where I got that 1 plus y prime from? Derivative of the inside function, right? And it equals negative 1 over x squared, right? If I don't have that shortcut memorized, I can use what rule? I could use the quotient rule, you're right. But power rule is quicker here, right? Right? If y equals 1 over x, that's x to the minus 1. Y prime is negative 1 times x to the minus 2, or negative 1 over x squared, right? So it's just our power rule. I'm solving for y prime, so I could distribute the cosine. It makes me work harder. I could divide here. So 1 plus y prime is negative 1 over x squared times 1 over cos of x plus y, which of course I could change to secant, right? Everyone agree? So I want to subtract 1, and I got my y prime. So the opposite of secant of x plus y over x squared minus 1. So not in terms of x, in fact, barely in terms of secant, because I have trigs and non-trigs, right? So this is one where I would most likely just say solve in terms of x. Yes.
What you do is like do the calculus function of the function that you're given, second order function, and the derivative it equals the derivative of the
One more time, Eva, I didn't quite catch that. You said basically what you do is,
You do the cat in the box thing equal.
yes,
derivative.
yes, I'm always doing the chain rule. Yes. So I can get my secant. Rosie, question? No? It's okay if you do. I can get my secant, right, from, secant is the reciprocal of cosine, right? So I need these two sides, right? Yes? So I need these two sides, but I need hypotenuse over adjacent for my secant. So I get negative x squared over x squared times the square root of x squared minus 1 minus 1. And so my x squareds will cancel there. And I've got negative 1 over square root of x squared minus 1 minus 1. And in this particular case, simplifying doesn't do much for me, but I'm still going to do it to err on the side of, oh, Robert says if I have more than one fraction, I want a single fraction, right? So I just get an LCD here, and I get minus 1 minus square root of x squared minus 1 all over square root of x squared minus 1. So I used to say to my teachers, I say, well, how do I know when I'm finished? Right? How did I know I should have gone one more step there? And the answer is always, it's always a computer science answer. I want to say as much as I can with the least number of pen strokes. So here I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9. Here I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the one that I'm going to say is better.
So are you gonna take on points if we go a step further?
No, I would accept either in this case. In fact, I would rather you err on the side of, if you have fractions, make sure I have a single fraction. Okay? Because that's what's going to happen most of the time. And yeah, Marinata. Yes. Oh, it's 1 over. Damn, thank you. Shoot, Robert. Damn it, Robert. Damn it, Robert. Oh, I'm recording. You're the best, Robert. You're the greatest ever. So I get negative 1 over x square roots of x squared minus 1 minus 1. It doesn't change much, right? This one is better for pen strokes for memory. The other one is better for finding critical values. Thank you, Marinata. Nice. So lots to practice from 3.5. Again, the homework is posted for Tuesday. I won't have time to correct it before the midterm, so Tuesday you can, after I collect it, I'll answer any question you want, right? Please make sure you're checking your homework. Please make sure you're checking your homework. You should know if you have it right or not, okay? And if you can't get it, right, then you're taking a photo of it and say, Robert, will you do this Tuesday? Or can you give me a hint where I went wrong, right? If you do it before Tuesday. I almost will answer right away, unless I'm in another class or asleep or both. So put please put the homework in order as I've listed them on the website on Blackboard. Please staple, put your name on it, right? Question? Nice. Let's move on to the next section, right? So we're talking about here 3.6, inverse trig derivatives. Well, it turns out, right, and we're going to restrict our inverse trigs to sine, cosine, and tangent, okay? In fact, if I know sine, I know cosine. So I know that tangent of alpha, right, I'll say, sorry, tangent of theta is some ratio is equivalent to arctan of the ratio is alpha, is theta. So my trig function has an input of an angle, and it gives me the ratio of sides of a right triangle. The inverse tan, so I could say it as inverse tan of the ratio is theta, or I could say arctan. I like to use arctan, arcsine, arccosine, just because there's some confusion with that negative exponent at times. But they are the same thing, okay? So make sure you recognize both of them. They both are the same function. The first one is read arctan, the second one is read inverse tan. Arctan is inverse tan. They're the same thing. So now I'm not seeing a trig as much as I'm seeing an angle. So the question is, when I see an angle, what do I see? A trig. And if I see a trig, I see a triangle. So I've backed up another step. If I see an inverse trig, I see a trig, I see a triangle, right? So let's find our derivative of arctan. So y equals the arctan of x, right? This is a nice graph. We should be able to, realize what this arctan graph looks like. So you should notice something kind of interesting there in terms of derivatives. What do you see about in terms of derivatives or critical values? Yeah, well, so is there a horizontal tangent anywhere? Is there any top of a hill you can see clearly? No. Bottom of a valley that you see clearly? No. So I already know my derivative will not equal 0. There is a horizontal asymptote, yes. Right? Of what? Where does tangent have trouble? Negative pi over 2 to at pi over 2 and negative pi over 2, right? It doesn't exist, right? The slope is infinite, right? So that means inverse functions, the inputs and outputs switch, right? So this is a height of pi over 2 and a depth of minus pi over 2, right? So as x goes to infinity, arctan goes to pi over 2. So do I know how to do the derivative of the left?
Yeah.
Yes. How about the derivative of the right? Nope. Don't know how to do it. So, but I do know how to do a derivative of a tangent. So what I do is use my inverse function here, right? So as soon as I see an inverse trig, I see a trig. So what trig do I see? Tangent. Tangent of y has got to equal x. So now I'm going to do the derivative of both sides, right? So I'm going to do the derivative of tangent of y on the left and the derivative of x on the right. On the left, I'm going to use implicit, right? Because I have an argument of y, so I only know the derivative is y prime, right? So what do I get? I get secant squared of y times y prime is equal to 1. I forgot something, sorry. Inverse tan leads to tan, leads to a triangle, right? So my triangle is what? Oh, same as before, right? X, 1 square root of 1 plus x squared. Everybody with me? Inverse trig gets me a trig gets me a triangle. I will probably need to use the triangle to get back to what I want. Nice, so I'm solving for y prime. I get y prime is 1 over secant squared. Right? Remember my argument here is y. My angle is y. I could just go to my triangle now, or I could convert this to cosine. Either way, I get what? 1 over square root of 1 plus x squared quantity squared. So I finally get y prime is 1 over 1 plus x squared. How we doing? So this is going on my formula sheet, right? If y equals arctan of x, y prime is is 1 plus 1 over the quantity 1 plus x squared, right? There's my derivative. In fact, we should have a chain rule version of it. Y equals arctan of some function u gives me y prime is 1 over 1 plus u squared times u prime. Right? If the function inside is complicated, I got to make sure I'm doing the chain rule. So we're going to have 3 of these on our formula sheet. One for inverse tan, one for inverse sine, one for inverse cosine.
Question.
Yes.
So for the one over secant squared y, can you tell me how you got
Yeah, so secant is hypotenuse over adjacent. Hypotenuse over adjacent, right?
Yeah.
So it's really this, but I just ignore the 1. Right? I'm putting the secant piece in from the triangle. Nice. Now that we have this derivative, let's do a problem with that derivative. Okay? Yep, stay right here. Yep. Yep. Okay, nice. Ian, let me know. Okay, nice. Okay, no problem. Nice. Let's see if we can do a problem, right? So I have memorized, I have on my formula sheet anyway, y equals arctan of x of u gives me y prime is u prime over 1 plus u squared. Everyone okay with that version with u in it? Yeah, so it's just some other function, right? So like if I have y equals the arctan of x squared, right? Let's find y prime. And the critical values. So first thing I like to do here is graph this, because I'm not that familiar with the arctan function, right? On my calculator, I would do what? y1 equals tan inverse of x squared, okay? There's a tan inverse button directly above your tan button, right? See that? Take a look at that real quick for me on your calculators. Right, and I get this picture. Almost perfect. You can kind of see that compared to my tangent arctan function, right? What does it do with all the negatives? It moves them up as positives, right? Yes, you with me there? So I can already see something about my first derivative. What do I notice about my first derivative? Well, those are one of those slopes is negative, one is positive, right? But at 0, I see the bottom of a hill, right? Where my skis will be horizontal. So I know I'm going to have a numerator that equals 0. You with me? Good. Using my formula, I get, what is u? U is the inside function, that's x squared. What is u prime? And what is u squared? X to the 4th. So I'm ready now. I get y prime equals 2x over 1 plus x to the 4th. There's my derivative. Notice, don't zoom, Robert. Notice that the numerator is 0 at what x value? 0. Numerator is equal to 0 at x equals 0. When is the denominator equal to 0? Never, right? 1 plus something to the 4th power is always positive. Remember, we're not dealing with complex numbers in this class. That's like a 300 level calculus class when you have complex numbers in it, which none of you will take. Unless you change your major, like I did. I realized I wasn't nerdy enough to be a computer science major. What about the second derivative here? What would you do for the second derivative? Quotient rule, right? Let's race. Anybody get the double box for the derivative? And then I found my two critical values. I set my numerator equal to 0, and I have plus or minus 4th root of 1/3. What is that telling me? They're right about here. Plus or minus 4th root of 1/3, those 2 points. What am I doing with my car steering wheel? I'm originally turning, right, I'm looking above at that road, traveling on that road, right? Turning to the right, I hit that first black dot, I'm turning back left. I hit the second black dot, I'm turning back right. These are called points of inflection. Anybody get that second derivative? Only one student got, thank you. 2, 3, anyone else? Nice. Let's do another inverse trig, okay? So let's do sine. Let's do the inverse sine.
Wait, I don't understand, how this bottom part is there.
Yeah,
I
so
understand
I got the derivative, right?
Yeah.
I got the derivative. And I'm interested because what we're going to do in chapter 4 is we're going to find the critical values, right? So anytime we get a derivative, we want to find the critical values of it. Anytime we find a second derivative, we want to find the critical values of it. Say again?
One, so you can do one on the other side, like -1.
No, once I take a square root, an even root, that's when I get my plus minus.
No. When you put originally, when you put like from the left,
Here?
no, down.
Yeah? Here?
1 minus 3x before equals 0. When you put it on the other side, it goes -1 over 3.
-3. -1 over -3.
Yeah, all.
Yep. So anyway, I'm saying I know that downstairs is never 0, so I'm trying to find the critical values of the upstairs, right? 2 is definitely not 0, so I'm just looking at this factor, right? And I'm setting that equal to 0. So take that factor, set it equal to 0, right? It's the same as x to the 4th is 1/3, or x equals plus or minus the 4th root of 1/3. So those two x values will tell me where I'm turning my steering wheel. It's weird, but it's chapter 4, okay? On this midterm, I could ask you for critical values. What does that mean? When the numerator is 0 or denominator 0, right? What does it mean for an original function? X-intercepts or not in the domain. What does it mean for the first derivative? A horizontal asymptote, vertical asymptote, right? Horizontal tangent line, vertical tangent line. What does it mean for a second derivative? Second derivative means inflection points, right? Inflection points.
So for the overall problem, how did you know to find the second derivative?
I just decided. It's why I like math. I can pretend I'm God and just decide, let x be 2. Yeah.
Is there critical value for the denominator?
There is none, right? There is none. Right? Because x plus x to the 1 plus x to the 4th is always positive. So that denominator can never be 0.
When is it gonna ask us about
When is Robert going to ask you?
okay, when are you gonna
Chapter 4.
Okay, but we don't know what like the problems look like yet. Yeah, okay.
I hate waiting for the end of the movie, right? So, or the end of the book. I'll just read the last page. So I'm trying to give you a little glimpse into the future of what we're going to be doing So you could say, well, why am I doing this? Why does he keep saying I have to have this thing factored, right? It's because I want to find the zeros. All right, let's do inverse sine. So I want to find y prime if y equals the arc sine of x. So when I see an inverse trig, I don't think in terms of arc sines. I think in terms of sines. So I'm going to change this function into what? Sine of y is equal to what? X. Then I see a triangle, right? So it's the triangle I had before. Sine is opposite over hypotenuse, so this must be x, this must be 1, and the other side is square root of c squared minus b squared. So it's a little different. Does anyone want to see that with Pythagorean theorem? So the 1 and the x are obvious, right? For opposite over hypotenuse. So, but I'm going to pretend I don't know that last side. I just zoomed. Don't zoom, Robert. So this is my alpha. This is my x. This is my 1. This is my a. So I know a squared plus x squared is 1 squared. So a squared is 1 minus x squared. So a is square root of 1 minus x squared. So when I give you a trig, two sides are known, the other side is unknown, and you're using Pythagorean theorem to solve for that. Nice. So I'm ready to take my derivative, right? I'm doing d dx of both sides. So I'm doing d dx of sine of y equals d dx of x. Everybody there? Left-hand side, derivative of sine is cosine, but I need also the derivative of the inside, which is y prime. And on the right side of d dx of x is 1, right? Solving for y prime, I get y prime equals 1 over cos of y. And of course, I could write that as secant of y. It's your preference. But I still have to go to the triangle, right? So the triangle, let me remind us of our triangle. I forget already. Is it x and 1 and square root of 1 minus x squared, right? So I need my secant here, right? So I get 1 over square root of 1 minus x squared.
I just didn't parentheses. I just plugged it in.
That's fine. You'll still get the same answer, right? It's your preference there. You don't have to do your arithmetic the way I do mine. I always say there's more than one way to skin a cat, but my advice is to start with a dead cat. You know, there's something you should do, right? You should draw the triangle, right? That should happen. That's the way you start this. And then there's some, and that's why I love math. There's some improvisation in here that's fun. We need two formulas. If y equals the arc sine of x, y prime is 1 over square roots of 1 minus x squared. And if y equals the arc sine of u, right? Some arbitrary function that's not x, then y prime is u prime over square root of 1 minus u squared. So we want both of those on our and then you do the last one. You do the cosine one, okay? You find out that derivative. Let's do some problems. Let's take a break and then do some problems from the book. Let's take 8 minutes. We'll come back at 10:15. So this is 3.6. Inverse sine of rad 3 over 2. For those of you that are struggling with your trig, I suggest you doing all of the problems, or at least the odds, here in 3.6. So I personally, I'm going to show you how I do one, okay? And it's probably going to screw you up, but that's okay. Inverse sine of rad 3 over 2, right? So I want to find inverse sine of rad 3 over 2. Well, first of all, what's the output of an inverse trig? Right, an angle, right? Theta. But I don't think in terms of inverse trigs. I think in terms of trigs. So I know this is sine of theta is rad 3 over 2. And the first thing I'm trying to think of is what is my reference angle? For rad 3 over 2, is that pi over 6 or pi over 3? Good, pi over 3. So I know I'm cutting pi into 3 or the whole circle into 6. But the only two triangles that work for me when I'm doing an inverse sine, right, are quadrant 1 and quadrant 4, because I need to have a one-to-one function. I need to have a function that passes the horizontal line test, right? So I know my triangle has to come from angle 1 or quadrant 1 or quadrant 4. Obviously, sine is positive in quadrant 1, right? So this has got to be my pi over 3. So the answer is pi over 3. And of course, you could check that on your calculator. You could do inverse trig of square root of 3 over 2 equals, gives you some decimal. Divide it by pi, you'll see 1/3, right? So a good idea to do a bunch of those if you're a little shaky on the trig stuff. If you're shaky on the trig, you're shaky on the inverse trig, right? Khan Academy trig course, jump right to inverse trig section, right? All right, let's get to some derivatives. Let's do 7. Sine of 2 times the arctan of rad 2. What? Let's do 5 first. Tan of the inverse sine of 2/3. Tan of the inverse sine of 2/3. So what do you see? You see it? 2 over 3, yeah. So what do you see? Well, you see a trig, but before that, you're looking for inverse trigs, okay? So I see an inverse trig, so I know inverse sine of 2/3 is some theta. So my problem is really tan of theta, isn't it? If I only had a triangle, I could answer it right away. But I see an inverse trig, which means I see a trig. So inverse sine of 2/3 gives me sine of theta is 2/3. And now I have a triangle, right? So this is going to give me my triangle of 2 is my opposite side, 3 is my hypotenuse, And the other side is what? A squared plus 2 squared equals 3 squared. It's square root of 5, yes? How we doing? Inverse trig gives me a trig. Trig gives me a triangle. Say again? So a squared plus 4 equals 9. A squared equals 5, right? Square root of 5. Well, we didn't do a derivative here, but again, this is the thought, right? They just want to know what the tangent of this is. So we're done, right? Tangent is what? 2 over rad 5. If I rationalize, I get 2 rad 5 over 5. Does anybody need to see the rationalization? Yep. So I know 2 over rad 5 is 2 over rad 5 times 1 is 2 over rad 5 times rad 5 over itself. We always do the irrational over itself. So I get 2 over rad 5 times rad 25, or 2 rad 5 over 5. It's just all this pre-cal crap starts coming back. Trig and pre-cal. Let's do another one. Sure. So inverse trig gives me a triangle. 90% of the time, you'll have to go back to that triangle. Thanks. Let's get to some derivatives. Simplify. Let's do derivatives. Where are my derivatives? Wait, is it asking me to find derivatives yet? No. Oh, find the derivative. Yeah, good. That one's kind of boring. We already did 18. I don't know how you, well, I told you the shortcut of ln, but that's okay. Let's do 24. 24 is more the speed I'm going to put on the midterm than anything else. Everything else is kind of reviewing that triangle process. A couple of you did the arc cosine. Before I do that, I'll talk about that arc cosine. If y equals arc cos of x, y prime is negative 1 over square root of 1 minus x squared. How many of you got that over the break? Yeah, nice. And so, of course, our real version is y equals arc cos of u gives me y prime equals negative u prime over square root of 1 minus u squared. Just you got it upside down. Just probably the triangle, either the triangle or just misreading the triangle. Okay, what problem was I doing again? 24, yes. Because I can't remember things. I gotta take a picture. So I want to find y prime if y equals the arctan of x minus square root of 1 plus x squared. Nasty. So you can see I've got a pretty nasty function inside of the arctan, right? So I know that u is x minus the square root of 1 minus x squared. I need a couple of things out of that, right? I need u prime, I need u squared. Yes? So what's u prime? Good, 1 minus 1 over the square roots. Keep the cat in the box and then take the derivative of the inside, which is minus 2x. Make sure everybody's with me there. Right? The square root function, the derivative is 1 over the square root function. Oh, sorry, 1 over 2 square roots, right? Sorry, thank you. Times the derivative of the inside. Yes? Everybody with me? So I can simplify u prime for sure. The negatives cancel, the 2's cancel. I get 1 plus x over the square root of 1 minus x squared. Yeah, question, Oscar.
Was it always a positive or was it always a negative when you had it positive?
Yeah, it started as a negative, right?
Oh no, in the square root.
Oh, shoot. Thank you. Thank you. It's a positive inside, and Robert screws it up again. Oh, I'm recording. Robert's the best. Robert never makes mistakes. So I get 1 minus x over square root of 1 minus 2's, no, the 2's canceled, right? And that's a plus in there still, damn it. Sorry. Let's double check here. Give me a second. Please double check that you agree with that one. Thank you, Oscar. Everyone agree?
Where did the 2x come from?
Yeah, derivative of the inside,
Oh, yeah.
right? Derivative of the inside, 1 plus 2x. Derivative of that is 2x. X squared. Sorry?
For the derivative of the outside, when you lower you bring the half forward, don't you give a minus?
Yeah, the minus is still there.
What about, you're supposed to subtract the half minus 1?
I did. That's how the radical went downstairs. That's a minus 1/2, right? It's easy to think of this here. Y equals square root of x is x to the 1/2. So y prime is 1/2 x to the minus 1/2, or 1 over 2 rad x, right? And so now all I'm doing is changing the cat, changing the inside. But then I still need the derivative of the inside. Ian, yes?
Yeah.
Nice. I don't want to simplify this yet. I think I can wait. I could simplify it first, but I think I can wait, okay? My gut's saying wait. I need u squared, right? So that's x minus square root of 1 plus x squared quantity squared. I don't want to touch that either yet, okay? I want to wait on that. Yes, you with me? Okay, here's my formula that I have written down. Y equals the arctan of u gives me y prime is u prime over 1 plus u squared. So I'm going to put that in first, right? I'm going to put everything in. I have a u prime, I have a u squared, right? Here we go. So for us, this is from my formula, right? On my cheat sheet. And so for my problem, y prime is 1 minus x over square root of 1 plus x squared. There's my u prime. All over 1 plus x minus square root of 1 plus x squared quantity squared. So now I'm going, okay, do I have to simplify this? Hell yeah, right? I've got to simplify something here. So looks kind of nasty, right? Looks kind of nasty. I'm gonna see if I can work on the downstairs first. Again, the calculus is done, right? The calculus is easy. The algebra, no, not easy, right? And we're gonna find out all your weaknesses and for your algebra, for your trig, for your arithmetic, right? And hopefully we can fix them by the final. I want to wait on the fraction and just work on the downstairs and see if anything happens, right? Yeah, some things will happen. So upstairs I'm going to keep. And downstairs I'm going to FOIL, right? I'm going to get an x squared. I'm going to get a minus 2x square root of 1 plus x squared. And I'm going to get a plus 1 plus x squared. Make sure you see that. Oh, sorry. That should all be negative, right? Yes. Make sure you agree with me there, please. I get an x squared. I get one of these, I get two of these. And then I get that last piece squared. Yes. Some things will go away. Not much. It looks like only the ones will go away, and that's fine, but the x squareds can be combined. And now I want to clear my fractions, right? Sorry.
Numerator can be 1 minus.
Yes, thank you. Pretty nasty. Horrible. One more time?
Could you go back up a little bit?
Yeah. Yeah, I mean, you know, it's better for you to try it again than worry about copying it. Of course, you can copy it. You can take a photo.
Could you go up like one more line up? Okay,
Yeah.
so right here, why is there a negative in front of that whole picture of the sorry, I can show it.
Oh, damn it. Because I screwed up. So don't, so it should, that's a mistake. It should clean up better. It should clean up better than that.
That should be positive.
Just try it again. Let me do another one. Let me try and save face. Oh God, they're all horrible. Let me pick one off of my test. Let me pick one off of a test. Let's go to last year's. Let's go to that first midterm I have up there. Blackboard. I'm just going too fast, obviously, right? I'm going so fast that you can't copy me. I'm going too fast. So just try it again. You get the idea. There we go. Tangent of the arc sine of x over 2. Find the derivative and the tangent line when x is 1. Perfect. Find the derivative in terms of x, and then find the tangent line when x is 1. Yes, you with me? Okay, I'm going to write the problem down so you don't have to worry about copying it here. And I'll slow down a little bit. Slow down, Robert. That's all you got to say to me. Or you can say, Robert, how many cups of coffee did you have today? Y equals the tan of the arc sine of x over 2. Okay, we're looking for angles. Do we see them? We got an inverse trig, so we're looking for angles, right? This is really tan of theta, right? Should be an easy problem, right? So we know that theta is the arc sine of x over 2. But we don't like to think in inverse trigs. We like to think in trigs because they're simple. So I know that sine of theta has got to be x over 2, which means I have a triangle, right? What are some of my sides? Yeah, x has got to be the opposite. The hypotenuse has got to be 2. And the remaining side has to be c squared minus b squared. Square root of c squared minus b squared. So far, okay? Speed okay? We're all caught up? The Pythagorean? Yep. So I'm looking at this triangle, right, with a side of a side of x, and a side of 2. And I know a squared plus x squared is 2 squared. So a squared plus x squared is 4. So a squared is 4 minus x squared. So a is that square root. When I give you your midterm, it's going to feel like a book because it'll be 1 question per page and 14 questions and maybe 4 pages of scrap paper. Okay? All right, so we got a real simple problem here now. We know y is tan of theta, right? But we're going to ddx both sides, right? So what do I get? I get y prime. Derivative of tangent is? So secant squared theta times the derivative of the inside, which is what? Arc sine of x over 2 prime. Remember, theta is arc sine of x over 2, okay? But I don't need to write that. I need to get the secant squared from the triangle. okay? So let's work on our derivative here. What's u? What's the inside of the arcsine? X over 2. What's u prime? 1 over 2, yes. And what's u squared? X squared over 4. From my shortcut, I know if y equals the arcsine of u, y prime is u prime over the square root of 1 minus u squared. So I'm ready to write my derivative. Everybody okay with this box?
Could you break down what the U value?
Yes, so this is what's on my formula sheet, okay? And I know, right, we did that one today, but I did it with an x inside, right? But when I do it with a function inside, I have to make sure I'm doing I have to get the derivative of the inside. That's where u prime is coming from. No, yes, so x over 2 is a mx plus b, right?
So whenever you're using u, it stands for the,
In the original function, the argument of the original function, yep. Which one? Yeah. Hold on, Grace. Go ahead, Grace. I'm sorry, I can't. Just a little louder for me. I'm old.
well, this takes you from this actually now to the new,
It's an mx plus b, right? It's 1/2 times x. So it's an m. X over 2 is 1/2 times x. Right? We agree with that? X over 2 is 1/2 times x. So you can see the mx plus b. Yep, good. All right, I'm ready. Y prime is secant squared theta times what I got for my derivative of the inside, which is 1/2 times over the square root of 1 minus x squared over 4. Secant squared theta I can get from my triangle, right? Secant squared I get from my triangle. So secant squared is 2 over, right? It's 2 over the square root, but quantity squared, right? So 2 over square root of 4 minus x squared, right? Quantity squared times this. Notice I've got fractions within fractions there, right? I want to get an LCD here. So all over 4. Well, some things simplify, don't they? Make sure you're with me here. You see where I got my secant squared from? This is my secant, right? From the triangle, yes? But then I'm squaring it. And the other piece is my derivative of my arcsine, right? So then I'm going to just clean things up as much as I can. So when I square this, I get 4 over 4 minus x squared. I still have a 1/2, but I'm going to take out that 4 from the square root, which is a 1/2. Agreed? This 4 in the square root came out as a 2. Anybody agree? The 1/2s cancel. So I got 4 over 4 minus x squared times square root of 4 minus x squared. Well, that simplifies. Of 4 minus x squared to the 3/2 power. There it is. Again, the calculus is not tough. The arithmetic is tough. The algebra is tough.
So why was there a 1/2 in the denominator? Like,
Yeah, so-
I mean, I saw you canceled it out, but like, why was it there?
So there's a square root of 4 there.
Oh, yeah, so you took it off.
So that's the square root of 2 coming out in the denominator of the denominator. Ryan, question? They got line numbers on there now.
You go down to
Pretty beastly, isn't it? Pretty nasty. But this is our last piece that I'm putting on the exam. Another? I think that the trickiest part right now is that when you're going to do a derivative of an inverse trig of a complicated function, that you're getting my process of u prime, u squared, right? And then go into the formula, the memorized derivative. Okay, we ready? Nice. So I'm looking at my old test here. Well, that was it. Look at that. Pretty short. How many questions do you see there? There's 10. Find the limit using an LCD and a conjugate. Find the limit using L'Hopital's. 2 questions. Find the derivative using a limit and verify using a quotient rule. If secant of y minus x is 1 over x, find the derivative in terms of x. This one is that implicit one, right? Find the derivative in terms of x. We did that one today. Number 4. It says use the ln trick. I'm skipping that, but you could do this with what rule? Product rule. So it's easier to do this. So this one I would not include the ln trick in there. So you could do this whole test now. And we just did this one. Oh, I didn't finish. Tangent line at 1, right? Right? Let's get our tangent line at 1 because you all need help on this. All right, so the original function, right, was what? Tan of the arc sine of x over 2. And I had x equals 1. What's y equal? It's the tan of the arc sine of 1 over 2, right? What's the arc sine of 1 over 2? Pi over what? Very good, class. Pi over 6. What's the tan of pi over 6? Thank you, square root of 3 over 3. And I need the slope. So I need m at y prime of 1, right? So I got 4 over 4 minus 1 squared to the 3/2 power. So that's 4 over 3 to the 3/2 power. So that's 4 over what? Square root of 3 cubed, right? What is that? Cube root of, oh, it's 3 rad 3. And if I rationalize it, I get 4 rad 3 over 9. Everybody with me? Anybody with me? Calculus was done a long time ago, right? Just doing the tangent line now. I need an x, I need a y, I need a slope. So my tangent line is going to come from y minus rad 3 over 3 equals 4 rad 3 over 9 times x minus 1. I can feel the love in the room when I give you a tangent line like this. I have an ex-wife. I know when people hate me. It's for your own good. Damn it. These problems seem absolutely hideous until you get in there and do them all. Do them all. Do every one on my test 3, every one on my midterms. Do every one in the book. Well, that midterm you can do, right? That midterm you can do everything but the ln trick, but I'm skipping that this semester. Yep. Let me number and then I'll come back to it, okay? And you're going to check everything on this midterm, right? You're going to check everything on the midterm. Ready for another? Yep. What's the toughest part there? The what? The algebra. Yeah. The calculus is easy. Everything we've been doing to you for the last, I don't know how many years, was to get you ready for calculus. You're going to see we're going to complete the square again. We're going to do everything again. Everything we learned, we're going to use in this class, and Calc 2, and Calc 3, and DiffyQs, most of it in linear algebra. If you didn't have masks on, I'm sure I would make you smile if you're a bio student and know that you only have to do Calc 2. Depending on what school you go to, right? You still should research that. If you don't have to take Calc 2, don't take it. If the school you want to go to doesn't need Calc 2, but make sure you check your backup school and your guarantee school, right? You're a bio major or a biochem major, make sure you're checking all of those schools you want to go to. I regret not applying to the hell no, I'm not going to get there school. That was Princeton. I got into school for rejects from Princeton, Rutgers. I also regretted not applying to a school just for a location. Like I've always wanted to live in New York City. I have, but at that time I didn't, right? So you want a location school. You want the super difficult, challenging school. You want guarantee in. You want you want the public school like University of Maryland, not public, but you know what I mean. State school, right? And then you want a cheap school. You want to find the one that's the cheapest too. You want that on your list when you're applying. Let's do another one. So that was midterm from 2020. Let's look at 2000. Oh, don't I have fall 19? I don't. This one's a little bit complicated. So on this one, certainly could do the first one, second one. Third one is a limit at infinity. I'm not doing those, right? So third and fourth one we're not doing, limits at infinity. 5 is a nice one for continuity. 6 is our inverse trigs. So I certainly could do that one. 7 is an inverse trig, but you're doing a second derivative and finding critical values, so that's an easy one. 8 is a product rule, right? 9 is an implicit. 10 is an ln trick, so we're not doing 10. Yes? And 11 is an implicit. We didn't talk about that one the other day, but that's a good one to do. So let's do number 6 and then quit. Ready? Oops, wrong button. So I've got y equals the tan of the arc sine of x minus x square roots of 1 minus x squared. So I want y prime in terms of x. Okay? Well, do I see anything of interest? I see an angle, right? So I see an inverse trig, which means I see a trig, which means I see a triangle, right? So if I know that theta is the arc sine of x, I know sine of theta is x, and I know my triangle is x for the height, 1 for the hypotenuse, and the square root of 1 minus x squared for the adjacent side. Everyone okay there?
Okay, before we get super into it, what is the question asking?
Find y prime in terms of x. So I need that piece, right? Because I'm going to have to use the triangle to get my secant squared, right? Do you see where the secant squared is going to come from? Yep. Right? Derivative of tangent is secant, right? Secant squared. All right, we're ready. Y prime is secant squared of theta times theta prime. Minus the product rule of x minus x times square root of 1 minus x squared. So I'm going to hold on to that too. I'm going to put a couple placeholders in there. Remember, I want to either work on pieces on the side or make sure I write a whole complete sentence when I'm doing this. Well, I think we can do the secant squared right away from the triangle. Do we agree? Yep, it's 1 over 1 minus x squared, right? We agree with that? Secant squared coming from the triangle, 1 over 1 minus x squared. Right, I took my secant ratio and squared it, right? Secant is hypotenuse over adjacent, right? Marinata? Say again? Yes, so 1 squared is still 1, and the radical squared becomes without the radical. Yep. I already know the derivative of arcsine, right? I've got this memorized. I got it on my formula sheet. It's 1 over square root of 1 minus x squared. My last piece is going to come from the product rule, right? So I'm going to do a negative of the product rule here. So first function is x, derivative is 1. Second function is square root of 1 minus x squared. Derivative is 1 over 2 square roots of 1 minus x squared times a negative 2x. So it looks like the x's will cancel. Sorry, the 2's will cancel, right? So I get a negative x squared over square root of 1 minus x squared, and the other product is just square root of 1 minus x squared. Make sure you see that. Make sure you agree with me. I did this green piece first, and I did this piece second. So it's a product rule, so I add, right? So the negative survives, right? Ian? The derivative of the inside. Derivative of the inside. So this is what I'm working on, right? Am I done yet? Hell no.
So,
Yep.
you also go over how to find the prime of arcsine.
Yeah, we did that. We did that today, so we have it memorized. If y equals arcsine of x, y prime is 1 over square roots of 1 minus x squared.
Okay.
Yep.
I don't understand why it's minus like this.
Yeah, so product rule is a plus in between. So this is positive and this is negative, so I just keep it. In product rule, I don't change any.
X value is 1 over 2 square root of 1 minus x squared. Oh, by negative.
Yeah, I'm doing, well, it's negative because I got the derivative of the inside is negative 2x. I just put it second because I didn't want to have the negative leading negative. Can I keep going?
Okay, so normally we do have it backwards.
Yeah, when I do product rule, it doesn't matter which of those cross kind of things I do first. So I tend to pick the positive. If one is positive, one is negative, I like to pick the positive one first. I can keep going? So I'm going to distribute that negative, and then I'm going to need an LCD, right? So y prime is 1 over 1 minus x squared times a 1 over square root of 1 minus x squared. By the way, that's my LCD. Plus an x squared over square root of 1 minus x squared minus a square root of 1 minus x squared. So I'm going to get an LCD here. So I need this LCD, right? I need that particular LCD. Right, so real quick on the side, I know my LCD is 1 minus x squared times square root of 1 minus x squared. Of course, that's 1 minus x squared to the 3/2 power, but I'll deal with that at the end. So I need here 1 minus x squared over itself, of course. And here I need a 1 minus x squared and the square root of 1 minus x squared all over itself. Calculus is done. Algebra hell begins. Look at what I got. I've got a single denominator now. Right? I've got that single denominator now. Every denominator is the same, and I just got to see what I have upstairs. So I got a 1, right? Plus an x squared minus x to the 4th minus a whole bunch of stuff. It looks like a 1 minus x squared quantity squared. Make sure you agree with that. Right? The rad times the rad is another one of these, right? So it's a 1 minus x squared quantity squared. I'm going to simplify that. If you don't have a headache yet, I don't know what's wrong with you. I have 1 minus 2x squared plus x to the 4th all over my LCD. I'm going to distribute that negative. Nice. I'm almost there. The 1s go away. The x squareds give me a 3x squared, and the x to the 4th give me a minus 2x to the 4th over 1 minus x squared to the 3/2. Only one more step, sorry. I can take out that x squared upstairs, right? I guess there could be one more step. That is a difference of squares, right? I could. Yes, exactly. I could factor that one last thing, but this is fine. I could factor that, but this is pretty good. Pretty nasty. Yep. Let me number. Remember when I was saying some problems take a couple pages? Yes. Sorry I gave you all a headache today. It's a good idea to, bring up right before, 15 minutes before class starts. About 500 milligrams of Tylenol should do it. You can go to Costco and get the big jug, and you're walking around, you can hear shh, shh, shh. All right, have some fun. Try and make it fun. It's just a stupid game. Yes. What is that?
Last year.
Oh, yeah. Yep. The calculus is easy. Marinata, yeah. Yep. What number? Yep. All right, see you Thursday. Everyone got their homework turned in?
Send you the invite link right now, and then I'm gonna be sending you periodic reminders like every few days.
Yeah, no, I once I send the letter, I'll tell you.
Okay, and then I'll get an email anyway. that
Yes,
says that you
exactly,
completed it.
exactly.
Thank you.
Hey, oh yeah, yeah. So I'm okay with extension on homework.
Okay.
So you can turn homework in Thursdays instead of Tuesdays.
Yeah, I was not at all thinking about the
Yeah.
test.
Okay, yeah,
That-
so but the
that
test,
was, like, really
yeah,
shocking
that's
me.
fine.
Yeah.
And now we do have one project,
So how long?
but I'm giving you the project right after spring break, and
Uh-huh.
you have till the day of the final to do it.
Okay.
I can't extend it further than that.
Okay.
But,
I mean,
and
it's-
that's gonna be a group project,
okay.
if you want, because I know you have a study group, so you could do it with your study group.
I have 8 at this point. So, okay, so, but what were you saying about the homework though?
But you can give it to me Thursdays.
Thursdays.
I'm okay with that.
Okay, so the only
So it gives you
thing,
2 extra days to do homework.
cool. So the only thing is, I just have to have that in the email. So just email it to you again, just saying.
That's fine.
Because it has to be
That's
written
fine,
down somewhere.
official, yep.
Okay. All right. Thank you.
You got it, thanks. What's up?
I was wondering if I could come to your office hours.
Sure, Thursday.
Every morning to practice some questions.
Sure. So what I would probably rather do is come here. So I could come here and we could work on some things here.
Early?
Yeah.
Because I always come around 8 here.
8?
Yeah.
Yeah, we could do that. So when you get here on Thursday, send me an email and I'll come over.
Oh, okay, thanks.
All right? What's up? How you doing?
Another open up my calculator. It only graphs.
Let me see.
It only graphs one part of the wire.
So I like Zoom standard. Zoom 6 should get me back to a regular window.
Okay, thank you.
And then, so most of the things I give you, Zoom standard will work for the picture.
Yeah, I take care of some kids sometimes, I babysit,
And
and,
that-
they'll play with
Yeah.
it. So I know I've been having trouble during the
Yeah.
homework and the test.
Yes.
I always have an issue with the graph because I don't know how to take.
So on the homework, use Desmos, okay? And then if it's a quiz, just call me over. Quiz or a test, call me over, I'll fix it quick. The real good trick is, let me have it, is there's a memory in here, okay? See this blue button, memory, MEM? If you hit second memory, you can reset your memory and it will get everything back to the standard ready to do stuff mode. Okay?
Thank you.
Yep, you got it.
Thank you so much.